Hola, Mr. Sutton here with the Pre-Cal Honors 2-4 Part 2 homework solutions on graphing polynomials in intercept form. For this graph, let's start by getting the x-intercepts, or zeros, or roots of this polynomial. So this x plus 1 gives us a 0 of -1, because that's what zeroes out that factor. X minus 2 gives us a 0 of 2. Putting those on our graph, -1 is somewhere over here to the left of the y-axis, and positive 2 somewhere over here to the right. Now let's get the y-intercept by plugging 0 in for the x's. So we essentially have a -1 cubed times -2. So that's just a -1 times -2, which is positive 2. And that's somewhere up here on the y-axis. Next, let's get the end behavior. Just looking at the x's, if we were to expand everything out, we've got a negative, we have an x cubed, we have an x, and if we multiply all that together, that's a -x to the 4th, -x to an even power. So that's going to behave like a -x squared, an upside down parabola. So we're going to start below the x-axis and end below the x-axis. Next, for the root behavior, we have -1 came from a cubic factor here. So that's a triple root, meaning we are going to flatten as we go through -1. And 2 came from a single power factor, so that's a single root, so we're going to just cross through that like a line without doing anything else. So starting below the x-axis, we flatten through -1, go through the y-intercept, cross through 2, and we end below the x-axis just as our end behavior says we're going to. To graph this polynomial, let's start by getting our roots. So this x here gives us a root of 0. X plus 5 is a root of -5, and then we have a -3 as well for that last factor. Graphing those out, -5 is somewhere to the left of the y-axis, and then we have -3, 0's right on the origin, and that's also going to be a y-intercept because it's also on the y-axis. But if you weren't sure, you could plug 0 in for all the x's. You'd have -0 times 5 times 3, which would still come out to 0. For the end behavior, we have a -x times an x times an x. Overall, that gives us a -x cubed, or just a -x to an odd power. So that's going to behave like a -x, like a upside down line or a downward slanted line. So we're going to start above the x-axis and end below the x-axis. For the root behavior, all these factors are single power, so these are all single roots through which we are going to cross without doing anything else fancy. Starting above the x-axis then, we cross through -5, go back down, cross again through -3, cross through the origin, and we end below the x-axis where our end behavior predicted we would. The key to graphing this one is to start by getting the roots. So we've got 0, -2, and this last one is going to be positive 2 because that zeroes out that last factor. So graphing those, we've got -2 over here to the left of the y-axis, 0's the origin, and positive 2's over here somewhere. For the y-intercept, we've actually already got that because we have that origin point, but you could plug 0 in for x if you wanted. So 0 times 2 times -2 would still come out to 0. For the end behavior, we have an x times an x times an x. That's positive x cubed, or positive x to an odd power anyway. So that's going to behave a lot like a y equals x graph, like a line slanting up. So we're starting below the x-axis, and we're going to end above the x-axis. So now let's also get our root behavior. Since all these factors are first power, that means that all of these roots are single roots. So we're going to cross through all of them. So let's do that now. Starting below the x-axis, we cross through -2, come back down, cross through the origin, come back up, cross through 2, and we end above the x-axis where the end behavior says we're going to be. We'll start this graphing problem by getting the roots. For x squared, that gives us a root of x equals 0. And for x minus 1 squared, that's going to be a root of 1 because that zeroes out that factor. Graphing those out, we have a dot on the origin for x equals 0, and 1 is somewhere to the right of that. And now for the y-intercept, we've actually already got that right there, but you could plug 0 in for x if you wanted to and just double check it. So 0 squared times negative 1 squared would give you 0. For the end behavior, we essentially have an x squared times another x squared. That comes out to x to the 4th, or in general, we have a positive x to an even power. That means it's going to behave like an x squared, like an upward opening parabola, so that we're starting above the x-axis and ending above the x-axis. For the roots, at 0 and 1, those both came from second power factors, squared factors, so those are double roots, meaning we are going to bounce at both of those locations. So starting above the x-axis, we come down and bounce off of 0, come back up, come back down, and bounce off of 1, and we end above the x-axis right where we expected to. For this problem, let's start by finding the roots, which are going to be 0 for the x squared factor and negative 2 for that other factor. So graphing those, we've got negative 2 back here somewhere, and 0 is the origin. The y-intercept is also this origin spot. It's both an x and a y-intercept. But if you wanted to, you could plug 0 in for x just to check. So that would be 0 squared times 2, which would still give you 0. For the end behavior, we have an x squared rather times an x. So that would give you an x cubed if you multiply those. In general, that means we have a positive x to an odd power, which is going to behave like a line sloping up, like a y equals x graph. So we're going to start below the x-axis and end above it. In between, for our roots, this negative 2 was a single root. It came from a single power factor. So we're going to cross through negative 2. And 0 came from this double root here, this x squared. So that means we have to bounce off of 0. So now starting below the x-axis, we cross through negative 2, bounce through 0, and it looks like we're ending above the x-axis, right where our end behavior said we would. On this problem, let's go ahead and find the roots, or zeros, to start this off. That'll give us the x-intercepts, so that'll give us negative 3, x equals negative 3 for that first factor. Then we have negative 2, positive 3, and positive 8. So that leaves, let's see here, we got negative 3 is over here somewhere. Negative 2 is a little closer to the y-axis on the left, 3 is to the right, and 8 is even further to the right. For the y-intercept, we plug in 0 for all the x's, so that means we're doing negative 3 times 2 times negative 3 times negative 8, like so. And now let's multiply all of this out. So let's see here. We've got 3 negatives, so the overall result is negative. 3 times 3 times 3, I'll do those first. I know that's 27. 27 times 2 would give me 54. And 54 times 8, well, that would be like 8 times 50 plus 8 times 4. So that would be 400 plus 32. So this is negative 432. You could have used a calculator, but hey, we didn't. Anyway, that's down below the x-axis somewhere down there. Not drawn to scale, though. It's just a sketch. For end behavior, we take a look at what the x's and the sign out front are doing. So we have a negative, we have an x, and an x, and another x. So this is going to be negative x to the 4th for the lead term if you were to multiply all this out. In general, negative x to an even power. That means it's going to behave like an upside-down parabola, like a negative x squared. And now for the root behavior in between, all these factors are single power. That means these are all single roots, and we're going to cross through all the roots without doing anything else fancy. So starting below the x-axis, we cross through negative 3, negative 2, 3, and 8. And notice I went down here to go through my y-intercept as well. And notice that we also end below the x-axis, right where the end behavior said we will. To sketch this graph, we first need to find the x-intercepts. So zeroing out each of these factors, we have a root of 0, negative 6, and finally 3 for that last factor. Graphing those, negative 6 is somewhere over here to the left, 0 is on the origin, and 3 is somewhere over here to the right. The y-intercept is just this 0 that we got for the x-intercept. It's the same spot on the x and the y-axis. But if you wanted to, you could plug in 0 to double check. So negative 0 times 6 times negative 3, that would give you a y-intercept of, yes, 0. So now for the end behavior, we have a negative, an x, and another x in terms of the big picture here, if you were to multiply all that out. So that's a negative x cubed, in general, negative x to an odd power. That behaves like a y equals negative x kind of function, like a line slanting down. So that means we're starting above the x-axis and ending below it. Now for the root behavior, all these factors are single power, so that's all single roots. So that means that we're going to cross through all of those zeros. So then starting above the x-axis, we cross through negative 6, come down and cross through the origin, cross through 3, and we end up below the x-axis where the end behavior said we would.